Well, greetings and welcome to 90 Notes. Here we are in lesson 1.6 in our McGraw-Hill textbook. So let's check out those exercises. Well, maybe you got them done in class and you just want to go through them right now. Let's see how you did. Okay, the first one. A silly question. So which of these four constructions are going to help us construct a line that's passing through C that's perpendicular to AB? Oh, come on. An equilateral triangle with side AB? A hexagon with side CB or BC. You know, never said it was equilateral in here or regular, but I don't see how it helps anyway. Or a square with a side AB. None of those make any sense. The only thing that makes sense is our good old construction. We're going to start with our needle on C. We're going to swing a random arc. We could swing it to A or to any random point, and then effectively we're making the perpendicular bisector construction from here. You see how that goes. And then we're just going to get the line, and we'll line it up there, our straight edge, and there we go. So the only choice that made any sense was choice C, construction of a perpendicular bisector through C. Remember that first compass swing, which we put from C passing through A, could have been random, and it would just, it would still work. That was easy. Let's try number 2. Okay, let's read this one at a time. L, M, perpendicular to same line. All right, so I'm going to draw a line L. And there's the line N. It's perpendicular. L is perpendicular to N. Now I'm going to draw M, which is also perpendicular to N. Now, didn't say, but it should have said that they must be coplanar, because M and L could be skew. But so neglecting that, let's say we're talking in a plane here. In a plane, we would say that these guys must be parallel. So which of these statements would be true? Well, if I look at that, well, shoot. There's line D right there. Lines L and M are parallel. They're not perpendicular. So D rather than A. And let's look at this. L is perpendicular to N. So far we've got that and that. And finally, M perpendicular to N. So these three statements, clearly, they are the ones. Make sense? The other ones are just the opposite statements. Okay, let's go on to this. Yikes. This is the one we really want to focus on. We're going to make a angle bisector construction. Now, we've done this in class a bunch of times. Can you write it down? All right. Given a random angle, in this case BAC, I'm going to construct a circle A through B. I just did that to make it easy. You know that this arc or complete circle doesn't have to go through B. It could go through any place. You could draw the arc, you could draw the full circle. And that's going to generate, in step 2, I would say we're going to mark the intersection D on circle A. I guess more, if I was being really exact, I'd say mark the intersection of circle A on the ray AC as D. But I think we're pretty good right there. Then I'm going to construct circle B through D. Now again, I'm gapping it here. I'm going this far. If we were doing it the way we learned earlier, if we were just doing arcs, we'd stop there because we know it'd be good enough. But if we made complete circles, it would look like that. We would flip our compass around and construct a circle, well, D, well, let's mess that up. D through B. Okay? So now we've got it going this way. And you see the intersection we were looking for. And that's all we needed. Now, if we, okay, I'll put in the complete circle in case you sketch that. Now, I could say construct F, the intersection of the circles. But your textbook likes to point out that this is same as the perpendicular bisector construction of BD. So that also generates this point here. I'm not a big fan of this, but it is true. That's the perpendicular bisector of BD right there, but I'd prefer just to use the point F, given that, well, what I learned was that the angle bisector is a ray, R-A-Y, a ray that divides an angle into two congruent angles. Not to mention, if this angle were obtuse, point E would be on the other side of the vertex. But I'm sure we'll come across that more and more in this text. All right, so as far as what I expected you to write, you had to say something about maybe steps 1 through 5. I mean, okay, actually you probably need them all. So go ahead and write that down to the best of your ability. Okay, next page. Let's flip the page over. We're on page 42. This is a compass construction. Which statement has the same length as EA? Yikes. Well, where is EA? Well, EA is, I'll draw a little segment. EA is over here. I'm going to pick a different color. Let me pick something a little, pick the blue. It stands out a little better. So what's the same as EA? And I think we've gone through this before. We know that EA is the radius of the circle A. Well, so is this, but we don't know the name of that point. The two circles are congruent because they have a radius AD. Therefore, ED is a radius of a congruent circle. And of all of these, this one makes sense. So EA congruent to ED. Not so much the other ones. BD, nope, over there. BE, nope. EC, no. None of those make sense. Okay, let's go back to this diagram. Number 5. Now, on a previous exercise, we were asked to construct, remember this? Or find, and there's a bunch of them, different equilateral triangles of different sizes. So we would call those similar. I don't know if we've seen that word in this textbook yet, but they're similar, not congruent. However, here, we're asked about this. Which of these are equilateral? And I would definitely go for the blue here, because we've seen this clearly. Each of these sides is composed of a diameter. Diameter of this circle. I've got a diameter of this circle. And over here, ZW, I've got a diameter of this circle. And all the circles being congruent that we've demonstrated many times over. By contrast, down here, triangle STU is isosceles. We've got two congruent segments there, not congruent to that. So I'd go for the blue. Which one is equilateral? How do you know? Well, put it in your words. Hey, says next page. Let's go. All right, number 6. So this diagram again, select all the segments that are congruent to AB. Congruent, you should say it this way. if you're being correct, you'd say congruent to AB like that. Okay, where's AB? AB is right here. So AB is the radius of this circle. All right? So if AB is the radius of this circle, so is AC, so is AH, so is AD. AH. All right, so this one is a yes. Where's HF? Well, HF is over there. I don't agree with that. CE, no. CD, no. How about BD? Now, BD, I like this, is the radius of this circle. And I can also say AB is also the radius of that circle as well. So these two are congruent. And where's BF? Well, BF is over here. And again, it is also a radius of this circle. So look at these three, BA, BF, BD, are all radii of that circle. So I'm going to give a yes to these three. And over here, I'm looking at HF. Well, HF is twice the radius, or the diameter. So this is clearly twice as long as AB. So that one's going to be no. I'm looking at CE. Well, CE is not a radius at all, and CD is not either. So none of those are radii. So we have three of a kind. Okay, let's move on to 7. Name the pairs of perpendicular line segments. Oh, I gave it away. Dang it. All right, compass bisector here. Name a pair of perpendicular lines. Even though I said it this way, I'm not comfortable saying, okay, they said segments. Technically, you could say the segments CD is perpendicular to AB. I guess the segment CD is contained within the line CD. So I'll give them that is true. Now, name a pair of segments with the same length. Yikes. Well, there's a couple ways we could go here. I could say AM, for instance, is congruent to BM because I know the perpendicular bisector divides this segment into two congruent segments. So I could say, can I see the keyboard? It's getting dark out here. AM, AM, where's the M? AM, and I'm writing it this way. The measure of segment AM is equal to the measure of the segment BM. That's a true statement. And I could make use of any of these other statements here. I could, for instance, say AC is congruent to BC, or I could have said AC congruent to AD. So I'll just pick one of those. We're just looking for one statement, one pair. We didn't need to name them all. So I'm going to go AC and say that's the same as AD. Okay, notice the way I'm writing it here. This says the measure of the segment AC is equal to the measure of the segment AD. That would be the, it said name a pair of line segments with the same length. So that's why I felt compelled to write it that way. Okay, last one. Oh, what am I doing? Last page. Here we go. Okay, in this construction, A is the center of one circle, B is the center of the other. Name the segments that have the same length segment as AB. Whoa. All right, well, this is kind of fun. So AB is clearly, and this is a review, we've seen this one before. AB has the same measure as AC. AB is also congruent to AD. So we're going to start out with AC. We're going to list them all. AC, And then here we'll put AD. Now I could look at it another way, and I could say, wait a minute, BA, BC, BD, BA, BC, and BD. There. Well, I think that's going to finish us up for tonight. So check your notes. Make sure I hope you're getting all this. And we'll see you back in class. And as always, thank you for watching Nani Notes.